Try to imagine something. Actually, close your eyes and picture this. 85% of everything in the universe gone, invisible, undetectable, but somehow still there, holding galaxies together, bending space, doing all the heavy lifting of cosmic architecture. You can't see it, you can't touch it, you can't catch it in any detector we've ever built. And for 40 years, the smartest people on Earth have been saying it must be some exotic new particle, some parallel dimension, some force we've never encountered. What if I told you they might be completely wrong? What if the answer was sitting right there the whole time and we just forgot to look? Put your hand on your chest, feel your heartbeat. The matter making that heartbeat, the carbon in your bones, the iron in your blood, that's normal matter. According to our best cosmologists, what you're feeling represents just 15% of all the matter that exists. The other 85%, we call it dark matter. Dark because it doesn't glow, dark because it doesn't interact with light, dark because we have absolutely no idea what it is. Or do we? See, here's what nobody talks about. This cosmic mystery, this 85% problem that's supposed to require exotic physics and revolutionary new particles, there's a solution that's been staring us in the face since 1984. Not 2024, 1984, 40 years ago. And the person who figured it out? Ed Witten, just one of the most brilliant theoretical physicists alive. The guy whose math you really, really don't want to question. But we ignored him for 4 decades. Physixal deneim commutu. Here's what Witten realized. Take a handful of sand, normal sand from a beach. Now imagine crushing it, not just pressing it, crushing it with the force of a collapsing star, crushing it until the individual grains merge, until the empty space disappears, until matter itself changes its fundamental nature. That crushed handful of sand, it would weigh more than a mountain, and it would be completely invisible. You learned in school that everything is made of atoms. Those atoms have protons and neutrons at their core. And those protons and neutrons, they're made of things called quarks. Up quarks and down quarks, the lightest ones, the basic building blocks of normal matter. But here's what your physics teacher probably never mentioned. There are heavier quarks. Strange quarks, charm quarks, bottom quarks, top quarks. We can make them in particle colliders, but they're unstable. They decay almost instantly back to the lighter ones. Almost instantly? Witten asked a simple question. What if you could get enough of them together? What if you could make a big enough clump? See, physics has this weird rule. Sometimes when you get enough of something unstable together, it becomes stable. Like people in a crowd, individually vulnerable, but collectively powerful. Witten's math showed that if you could gather enough quarks together, not just up and down quarks, but strange quarks too, they'd prefer to stay together. They'd form what he called stranglets. And these stranglets would be absolutely bizarre. A speck the size of a dust particle would weigh a ton. A marble-sized piece would weigh as much as 1 billion tons. These things would be the densest objects in the universe, denser than neutron stars, and they'd be electrically neutral. No charge, no interaction with light, completely dark. Do you see where this is going? What if dark matter isn't missing particles from some parallel universe? What if it's just normal matter, quarks, the same stuff you're made of, crushed into forms so dense, so strange, that we forgot it could exist? This caused panic in the physics community. Because if Witten was right, if strange matter is more stable than normal matter, what happens when they meet? Imagine dropping a tiny piece of strange matter into the earth. It starts converting regular matter into strange matter, atom by atom, molecule by molecule, spreading outward like crystallization. The whole planet becomes a ball of ultra dense quark matter the size of a city block. Science fiction? Maybe. But physicists took it seriously enough to worry about accidentally creating the stuff in particle colliders. For decades, we thought this idea was dead. The early universe, we believed, went through a smooth transition when quarks first clumped together into protons and neutrons. Smooth transitions don't make strange clumps. But we were wrong about being wrong. New calculations show that even without dramatic phase transitions, the early universe was chaotic enough, violent enough, correlated enough to form these massive quark nuggets. Some could be microscopic, others could be asteroid sized mountains of invisible matter. And here's the beautiful, terrifying part: these things could be everywhere, floating through space, passing through your body right now, tunneling through the earth, hitting the moon, and leaving tiny, perfect holes that we've never thought to look for. If a small one hit a star, it might convert just enough matter to change the star's spectrum in subtle ways. If it hit a white dwarf, it could make it more compact than it should be. The signatures are there, subtle, difficult to find, exactly what you'd expect if you weren't looking for them. So here's the question that keeps me up at night. What if the biggest mystery in cosmology isn't mysterious at all? What if we've been searching the cosmos for exotic new physics when the answer is made of the same quarks that make up your coffee cup? What if dark matter is just matter we forgot how to see? Think about that for a moment. 85% of the universe might be hiding in plain sight. Not in some parallel dimension, not in some undiscovered particle, but in a form of normal matter so extreme, so compressed, so strange that we convinced ourselves it couldn't exist. 40 years. 40 years we've been building billion-dollar detectors to catch dark matter particles that might not exist. 40 years of exotic theories and revolutionary physics when the answer might have been sitting in a 1984 paper by Ed Witten. Sometimes the universe isn't weird because it's made of weird stuff. Sometimes it's weird because normal stuff can do things we never imagined. And sometimes the biggest problem in science isn't missing data, it's missing attention. So the next time someone tells you dark matter requires new physics, ask them this: have we really exhausted all the possibilities of the physics we already know? Because according to Witten's math, the universe might be stranger than we thought, but not because it's foreign, because it's familiar matter doing unfamiliar things, and that might be the strangest possibility of all.